Section 6.4 is rectangles. First, we have the definition. A rectangle is a quadrilateral with 4 right angles. The definition could also be a parallelogram with 1 right angle. Because if you have a parallelogram and you have 1 right angle, they're all going to be right angles. So a parallelogram, opposite sides are parallel. It's a rectangle, so all the angles are 90 degrees. Other facts that fit with parallelograms fit with this. Opposite sides are the same length. That is a rectangle. Theorem 6-11 and 12. A parallelogram is a rectangle if and only if its diagonals are congruent. So that means that if this diagonal and this diagonal are the same length, so this is going to be a rectangle, if and only if segment RC is congruent to segment ET. And you can say that in either way. You can say if it's a rectangle, the diagonals are congruent, or you can say if the diagonals are congruent, then it's a rectangle. That's what if and only if means. Example, use rectangle math and the given information to solve each problem. We are told that HP is 10. We're supposed to find the length of MT. Now, one of the facts you'll recall is in a parallelogram, which a rectangle is, the diagonals bisect each other. And since we know the diagonals are the same length, it means each of these parts of these diagonals have to all be the same. So MT is going to be equal to MP plus PT. That's the segment addition postulate. And since both MP and PT are 10, that's going to make MT, sounds like I'm saying empty, 20. Moving on. Number 2. Measure of angle 1 is 40 degrees. That's this fella right here. Find the measure of angle 2. That's this fella right here. Well, check this out. This triangle right here is an isosceles triangle. How do I know? Because the diagonals bisect each other and they're the same length in a rectangle. So that means that since we have this isosceles triangle, the isosceles triangle theorem says that the base angles have to be the same. Therefore, we could say that the measure of angle 2 plus the measure of angle 2, because I'm saying that these two angles here are the same, so I'm going to call them both measure of angle 2, plus 40 degrees equals 180. The angle sum theorem. If you sum up all the angles in a triangle, you get 180. Measure of angle 2 plus the measure of angle 2, those are variables. If you add those together, then we have 2 measure of angle 2's. Keep in mind we're supposed to find the measure of angle 2. If we subtract 40 degrees from both sides, we get 2 times the measure of angle 2 is 140. If we divide both sides by 2, these 2's are going to cancel, and we end up with the measure of angle 2 equals 70 degrees. Moving forward. Draw a counterexample that shows that each statement below is false. A counterexample is going to make the hypothesis of the sentence true. So that's the hypothesis. And it's going to make the conclusion, it is a rectangle, it's going to make that false. So the statement here is, if a quadrilateral has one pair of congruent sides, it is a rectangle. Well, we need to draw a picture that shows a quadrilateral, four-sided figure, with one pair of congruent sides. And then show that it's not a rectangle. Now, to show this is not a rectangle for sure, I need to make sure I have an angle in here that's not 90 degrees. So this is a great counterexample. Makes the first part true. It's a quadrilateral with one pair of congruent sides. Actually, to make this more clear, we only want one pair of congruent sides. So let's say that this is 5 and this is 6. And is a rectangle, has to be false, and this is clearly not a rectangle because there's 20 degrees in there. Number 4, if a quadrilateral has two pairs of congruent sides, so that part's supposed to be true, then it's going to be a rectangle. That part is supposed to be false. So I could draw a parallelogram, and I could have two pairs of congruent sides. And as long as the angle is not 90, then it's not a rectangle. That's a counterexample. Makes the hypothesis true and the conclusion false. Number 5, find the values of x and y in the rectangle. So if we know it's a rectangle, there's lots of things we can mark in this. I'm going to hold off marking lots of things because the picture will be consumed with marks. I'm just going to try to put in relevant information. TR is 3x minus 12y. TQ is negative 2x plus 9y plus 4. ST is 3. Step 1, put your stuff in the picture. Now, the relevant information that we need for this is that the diagonals are the same length and they bisect each other. So we can make some equations from this. For example, we can say that ST is equal to TQ. ST would be 3, TQ would be negative 2x plus 9y plus 4. We could say that TR is equal to ST, so 3x minus 12y equals 3. We could also say that TQ is equal to TR, but we only need two equations. So I'm going to take each of these equations, since they have two variables in them, and we're going to make a system of equations. So 3 equals negative 2x plus 9y plus 4, and 3x minus 12y equals 3. And we are going to get one of the variables by itself in one of the equations. And it looks like to me getting x by itself in this equation is going to be the easiest. I'm going to add 12y to both sides and get 3x equals 12y plus 3. Then I'm going to divide each term by 3 and get x equals 4y plus 1. I'm going to take this equation and bring it down here. I'm going to move the 4 to the other side of the equation. By subtracting 4 from both sides, it's going to be negative 1 equals negative 2x plus 9y. I'm going to replace then the x with the 4y plus 1. So we get negative 1 equals negative 2 times 4y plus 1. And then we add the 9y in. Simplifying this, trying to get y by itself, going to get negative 8y minus 2. That's a distributive property. Plus 9y. Combine like terms. A negative 8y and a plus 9y is a 1y. And if we add 2 to both sides, we get 1 equals y. Once we know what y is, we can take this 1 and we can plug it in here into this other equation. So we got x equals 4 times 1 plus 1. 4 times 1 is 4. 4 plus 1 is 5. So this is the ordered pair 5, 1. That's the solution to this. The directions were find the values of x and y. It makes it a rectangle. We have done so. Number 6. Determine whether ABCD is a rectangle and then explain how you know it's a rectangle. Well, you got choices on how you can do this. Option 1, use the distance formula to find the lengths of all four sides. If you did that, and if opposite sides are the same, then you know it's a parallelogram. Then you could use the slopes to find the slopes of two consecutive sides, and if those consecutive sides are perpendicular to each other, then it's a rectangle. Option 2, use the slope formula 4 times, 1 for each side. If opposite slopes are the same, they're parallel, and if adjacent slopes are perpendicular, which would mean negative reciprocals, then it's going to be 90 degrees, so it would make it a rectangle. Option 3, find the midpoints of the diagonals. If they're the same, it's a parallelogram. Then find the lengths of the diagonals. If they're the same, then that makes it a rectangle. I'm going to choose option 2 for this problem. Let's first determine if ABCD is a quadrilateral. If it's not a quadrilateral, then it cannot be a rectangle. So I'm just going to make a rough sketch. A is 1, 2. B is 3, 6. C is 9, 3. And D is 7, negative 1. If I connect them in order, A, B, C, D, I should get a quadrilateral. Of course, when you get to the end, you got to go back to the beginning. So it's a quadrilateral, so this might be a rectangle. Once again, I'm going to choose option 2. I'm also going to bring this stuff down here just so I can see it. You don't need to write this twice. So I'm going to find the slope of side AB. I'm going to find the slope of the opposite side of that, CD. Those should be the same. I'm going to find the slope of BC and the slope of side AD. Those last two slopes should be the same. In addition to that, consecutive sides that intersect each other like AB and BC, those should be perpendicular. Slopes should be negative reciprocals. The slope formula is the change in y over the change in x, delta y over delta x, which means we subtract. Y values for A and B are 2 and 6. X values are 1 and 3. 2 minus 6 is negative 4. 1 minus 3 is negative 2. That reduces to 2. So I'm expecting CD slope to also be 2. Let's see what happens. Slope formula, change in y over change in x. Y values for C and D are 3 and negative 1. X values for C and D are 9 and 7. 3 minus a negative 1 is like 3 plus 1. 9 minus 7 is 2. That reduces to 2. So far, we know we have one pair of opposite sides that are parallel. Now let's find the slope of BC. Get the change in y over the change in x. So we got 6 minus 3 for the y values. Got 3 minus 9 for the x values. 6 minus 3 is 3. 3 minus 9 is negative 6. That reduces to negative 1/2. Now we expect that because this slope and this slope should be perpendicular to each other. To do that, you have to be negative reciprocals. If I reciprocate 2, I get 1/2. If I change the sign, I get negative 1/2. So far it's looking like this is going to be a rectangle. If the slope of AD is also negative 1/2, then this is for shiz a rectangle. AD, the y values are 2 and negative 1. The x values are 1 and 7. 2 minus a negative 1 is like 2 plus 1, which is 3. 1 minus 7 is negative 6. That reduces to negative 1/2. Opposite sides have the same slope, so they're parallel. Adjacent sides or consecutive sides are negative reciprocals, so they're perpendicular. So we're supposed to say whether it is or not. So I'm going to say yes, ABCD is a rectangle. And I'm supposed to say why? Because both pairs of opposite sides are parallel and consecutive sides are perpendicular. There you go. Please do homework 6.4. Have a wonderful day.